constraint of time, I would like to first call the presenters of the previous sessions. So, shoreline change assessment in Gorumara using DSAS model by Debisha Ghosh and Dr. Onurai. Is Debisha present here? Okay. Debisha, do you have the presentation? Where is the pen drive? Okay. Okay, Debisha, the podium is yours.
Good afternoon, everyone. Today I am here to present my topic on dissertation, shoreline change assessment in Ghoramara using DSAS model. So, to introduce you, the shoreline changes in Ghoramara is of rising concern because due to global increase in temperature, the sea level is rising and the consequences of which are escalating worldwide concern, mainly in the coastal and island regions. The missions of United Ocean Decade 2021 to 2030 focus on marine life and livelihoods, and my current work is aligned with these objectives as the livelihoods of the people of Ghoramara are also subjected to the influence of marine activities. So Ghoramara is also known as the sinking island. Ghoramara Island is located 30 km north of Bay of Bengal in the Sundarbans Delta at the confluence of Ganga, Meghna and Brahmaputra rivers in the Bay of Bengal. The island has contracted to less than half of its original size, and presently it is 5 square kilometer in size. So these are my aims and objectives. It aims to assess dynamic coastline and the nature of sinking island of Ghoramara. Objectives are to assess the spatio-temporal coastal vulnerability of Ghoramara Island, to assess the nature and behavior of shoreline changes of Ghoramara Island, to evaluate the impact of coastal vulnerability on the livelihood of the local residents. These are my data sources, and this is the research methodology. I have collected maps from Landsat and gone through image enhancement. Then I have went for database creation. This is my study area. Next, I have went for atmospheric correction of the images from 1988 to 2010, then for 2013 to 2022. Then I have done NDVI for 2013 to 2022 as well. These are the shorelines of Ghoramara for the selected years from 1988 to 2022. Next is the digital shoreline analysis model, which is a freely available software application in the ArcGIS software. It computes the rate of change of statistics for a time series of shoreline vector data. The parameters are baseline settings and shoreline settings, and also transact settings are important. Next, this is the this is the shoreline change analysis using DSAS. First, I have digitized the shorelines. Then I have generated a baseline following the present coastal line, that is of 2022. The arrows show the orientation of the baseline. From these baselines, transit lines are generated, and these transit lines are intersected by the coastlines at each point, and these intersection points mark the measurement of the distance from the present coastline. Next, I have calculated the endpoint rate and shoreline change envelope. Endpoint rate states the rate of change of shoreline for the selected years, and shoreline change envelope is the distance between the nearest and the farthest coastline from the baseline along the transit lines. So I have done that for zone B, zone C, and zone D. This is the minimum distance between the shorelines and the maximum distance between the shorelines. So I have also forecasted the condition of the shoreline that might happen after 10 years and 20 years, along with the uncertainty of both the shorelines. Next, after collecting a data of 110, I have done the descriptive analysis. Here, there are places from I have collected the samples, and the gender shows that male are more, and the religion composition is Hindus are more. In the marital status, married families have been found to be more, and maximum of the people are having primary level of education. Nuclear families are more in number. The major occupation of the households is labor, that is 37.3%. Next, the major problems of the island is erosion, followed by flood, cyclone, salinity, and drought. For last 10 years, the environmental hazards were mainly cyclone, saltwater intrusion, and flood, with cyclone being the maximum impacting. Major impacts of the cyclone, from Amphan and Yas, people have been impacted mainly, but among in between both, Yas has been the most impactful. From Yas, human loss, livelihood loss, and revenue loss were maximum. Household structure, maximum of the households are kacha in nature, and roof type of all the houses have been, maximum of the houses have been tin. So when I asked the people that are they willing to leave the island, all mainly most of them were telling that they want to leave. However, there lie certain constraints in their wish. So there are mainly 4 constraints, and inadequate belief on the government is the main constraint. So to conclude, the findings suggested that the island has been subjected to acute erosion over the years. The island of Ghoramara is fast reducing in size due to increasing sea levels. The livelihood is under constant threat due to diminishing size of the island, and the onset of natural calamities triggers the already eroding condition. Further work needs to address the level of vulnerability and livelihood crisis amongst the potential climate refugees of Ghoramara. These are my references. Thank you.
Thank you, Debisha. I request you to take the seat, and we'll have a question answer session after this session is over, after all the presentations are over. So now next, I would like to call upon stage Debadrita De for presenting the flood susceptibility and management of Darukeshwar River.
Good afternoon, respected audience. Myself is Debadrita De, MSc Geography Department of Adams University. Today is my topic of presentation is flood susceptibility and management of Darukeshwar River. Before starting the presentation, I would like to thank my respected supervisor, Dr. Partha Basu sir, for giving me an opportunity to conduct this minor research work under his supervision. And next, I would like to thank my university for giving me an opportunity to present my research paper in this conference. Before starting the presentation, first I need to give an idea that what is flood susceptibility. So, flood susceptibility means the proneness of a river towards the occurrence of flood, and flood management means the procedure by which we can reduce the vulnerability and risks of flood. This paper is mostly examining the causes behind the Darukeshwar flood, especially on the middle part. So next the question will come, why Darukeshwar River? We can say that Darukeshwar River is a proper example of a tropical river basin which receives huge amount of rainfall data during monsoon period, and rest of the other periods it remains dry. Beside this, we can see three types of flood in the Arukeshwar River Basin, which is flash flood in the upper course, monsoon flood in the middle course, and tidal flood in the lower course. So the reason of flash flood is the hilly areas sedimentation, which those sometimes choke the river channel and create obstacles to pass the water through river channel, and then it's create flash flood. In the case of monsoon flood, the huge amount of monsoon rainfall is mostly responsible. In the case of tidal flood in the lower course, the high tide level of Rupnarayan River didn't allow to pass the high and middle course water through the lower course river channel and meet with the Bhagirathi River. It allows the back flow of the river, and then it's create tidal flow. Now this is our study area. The Arukeshwar River is a most important river of the western part of West Bengal, and it's originate from Tilaboni Hill near Madhavpur in Purulia district and passes through Purulia, Bankura, a little portion in Purbo Bardhaman, and then it's enter in Hooghly and meets with Bhagirathi River. The total length of the river is 200.2 kilometer, and the total catchment area is 4,528.8 square kilometer. This is the our study area map. Now we have considered few objectives for our research. One is determine the flood frequency of the basin. Then we tried to find out the morphometric characteristics of the basin, which are influencing in occurrence of flood in the basin. Then we tried to find out the role of climate in occurrences of flood. Next, we have studied the perception of local flood affected people in terms of causes of flood, period of flood, problems and benefit of flood, and mostly in availability of governmental support during flood time. Next, we have tried to find out suitable measures for management of flood. Before analyzing the methodology, I must say one thing, that our methodology or research work is mostly basically empirical. That means geomorphological investigation and observation is mainly done for this research work. Beside this, we have also done field study, and we have studied also the experience and observation of local flood affected people. So we have classified our methodology in three types. One is field method. Next, first was pre-field method, then field method, and last is post-field method. Okay. Under pre-field method, we have done literature review. In field method, we have collected data, and we have done field study, and then we have taken some bedding samples. We have identified different beds, and then we have studied the levee portion, and in post-field, we have processed the collected data and come in conclusion. These are the literature review we have done. We have done total 30 articles, and with the diagrams, we have classified our papers in terms of the topic of research article and types of journal. This is the methodology-based classification. And in case of research gap, we have found out that no previous work has been done over the susceptibility and management of the Arukeshwar, so we have chosen this as our topic. Next, we have tried to find out the flood frequency of the Arukeshwar River, where we can observe that in recent decades, the frequency of flood is increasing day by day. This is the diagram of flood frequency. Next, we have tried to find out the flood level of different year. We have taken this image from the research paper of Dr. Biman Ghosh, where we can observe that not every flood of Bankura and Arambagh has crossed the danger level and extreme danger level. So we can say that not every flood of the Arukeshwar River is so devastating. Next, we have analyzed the season-wise rainfall graph of Bankura, where we can see the monsoon rainfall data is mostly high than pre-monsoon and post-monsoon. So we can conclude that the monsoon data can be reason of flood occurrence. Next, we tried to find out the fluctuation in ground level in pre-monsoon and post-monsoon in the case of Bankura and Vishnupur. Here we can see that in case of pre-monsoon, the groundwater level fluctuates between 5 to 12 meter in Bishnupur and 8 to 12 meter in case of Bankura. After monsoon season, the groundwater level comes to 1 to 2 meter in Bishnupur and 2 to 4 meter in Bankura. That means after the monsoon season, the water level comes towards the surface and it saturates the soil, which indicates the more surface runoff and create flood condition. Next, we have done morphometric analysis of Darukeshwar. Here we can see the mean bifurcation ratio is 5.14, which is high. Mean length ratio is also high, which is 3.36. Circularity ratio is 0.25. Elongation ratio is 0.4. Form factor is 0.12. So each parameter indicates the strong climatic and structural influences over the river basin. Next, we try to find the correlation of stream numbers with respect to stream order, where we can find a negative correlation, and the third and fourth order is not following the linear trend truly. In the second diagram, we have plotted average mean length of the streams and with respect to the stream water, where we can see positive correlation trend, and the second order is not following the linear trend. Here we have created a hypsometric curve, and hypsometric integral value also had been found out, which is 0.51, and we can say the river is in its mature stage. This is the map of structural control, where we can find out geomorphic lineaments and drainage parallel, structural lineaments and fault. The root cause of the shape of the basin and pattern of stream network is responsible. So from the study area, we have taken a few cross profiles. This one is for pool section, where we can see pool portion, Thalweg point, flat bed, and point bar portion, and we can also observe cliff in the right side of the section. Next, we can observe the cross profile of riffles, where we can see the bottom of the section is mostly flat. Now we can see the cross profile of dry bed of the Darukeshwar river, where we can observe two mid-channel bar and the levee portion also. We have also generated discharge value from the Manning equation. For pool section, it is 15.37 cubic, and for riffle section, it is 15.30 cubic. This is the cross profile of paleo channel, where we can see pool section at the left side of the diagram. These are some field images. Now we have identified 5 types of bedding. One is laminar bedding, then current bedding, cross bedding, torrential bedding, and fleshers bedding. We have also collected sediment sample from these beddings, and we have analyzed these bedding samples and showed the result with diagrams. From fleshers sample, we can say medium sand most dominating. From laminar and current bedding, we can see fine sand is most dominating, and from floodplain surface, medium sand and fine sand both are dominating. We have taken the inclination degree of sand bed of current bedding with the help of Branton compass, and the value is delineated 56 degrees southeast. We have identified different floodplains of Darukeshwar river. We find 5 types of floodplain in here. Next, we have also find out the geomorphological characteristics of Darukeshwar basin. We have find out total 8 types of geomorphological plains in here. Next, we have done the perception study of the local flood affected people. In case of frequency of flood, few have said that flood occurs each year, where most of the other person have said it occurs occasionally, and some of the respondents said that within 3 to 4 years major flood occurs. Most of the respondents have said the flood period is monsoon, and as the cause of the flood we can see natural and man-made causes. Most of the people have said only rainfall is natural causes for the flood occurrence, and others said sedimentation, rainfall, and few other man-made causes is also responsible. In the case of man-made causes, we can see that illegal construction over river channel is responsible, and then heavy sand quarrying is responsible also. A later respondent also said that lack of impounded is also responsible for occurrence of flood. For benefit and problems, we can see that most of the respondent has said that itself in agriculture, and others said there is no benefit of flood. Problems of flood, we can see the communication is major problem for flood, and others say communication, waterlogging, and crop waste is also problem of flood. Availability of government support. Just two slides. For availability of government support, we can see food, clothes, and financial help is getting to most of the people by government, and few received financial help from government, and others say no availability of government support. We have also done IFD curve on basis of the 1 hour duration of rainfall data in the case of Bishnupur and Bankura. Here where we can see in the case of Bishnupur, we can see that the intensity rainfall amount 6.22 millimeter per hour is not create flood. Over that, the flood situation created sometimes. And in the case of Bankura, we can see very low rainfall intensity also creates flood. So from the overall analyzation, we find out some reason of susceptibility of Tarokeshwar river. There is no dam to control the discharge of Tarokeshwar river. The river is in spate due to excessive rainfall. The excess water can't be transferred in the downstream direction because of high level of water in Shilabati and Rupnarayan river. A long process of sedimentation in the mature river has made the river shallow, and sediments are held by vegetated growth in riverbed. The vegetation growth in the riverbed is favorable for local fish culture, so they allow more vegetation growth. The depth of groundwater table is rather shallow and even dry. Even in dry season, groundwater table is available within a depth of 12 meters. The local people often dump garbages in the channel. It's also choked the river channel and creates flood. So for managemental suggestion, we can say need to construction dam or reservoir to control the excess amount of water. The restriction of pisciculture to reduce the growth of vegetation in the river channel. We need to make awareness in local people not to throw garbages in the river also. And we need to stop the illegal construction over the river channel. In acknowledgement, I would like to thank Dr. Abhishek Shandra sir, Dr. Shuman Chatterjee sir, and Dr. Rajiv sir for helping me in this project. I would like to thank my friends Roshan Das, Priya Mujumdar, Jita Ditto Bhor, Shayanti Dev, Simran Kumari for helping me in this project. Okay, sir. Okay, sir. These are the references. Thank you.
Okay, thank you, Dibadrita. So I would like to ask to the audience if there is any question for Debadrita, Devisha, or other presenters who have presented before lunch. Is there any question for them? Okay. So if there is no question, then do you have a question? Yes, please, Shaman. To whom you have the question? Last presentation? Fast presentation? Okay. So I would like to request the first presenter, Shoniti Hembrom, if you are there. Yes. So here's a question for you. Shinchan, could you please provide them mic?
Hello.
Yes, please.
discuss this stone mining. So my question is, if the stone mining increasing day by day like this, what we will get the result for upcoming year?
Okay. So I would like to ask the presenter, did you understand the question and would you like to answer
Okay.
it?
So it is the contemporary debate between the extraction, natural extraction, and resource commercialization, and the destruction. So there is a no line of concluding the point that what will be the we know all ki there will be the destructive thought, I mean thing is there, because village and the land are degrading day by day, but we need to think as a sustainably or more towards to the preserving the agricultural land and the village and the settlement. That is the main point, I think.
Okay.
Yes, sir.
Suniti, I
Yes,
think.
sir.
Suniti, it was a very good paper, but I think you have mostly concentrated on spatial concentration
Yes, sir.
of that mining and I should say shrinkage of settlement area,
Yes,
etc.
yes, sir, yes.
But other aspects are also there.
Yes, yes, definitely.
You have not highlighted those.
Yes.
Please include those also.
Okay, okay, definitely. Sir, here I only tried to analyze the three things, that is the mining and the settlement and the agricultural land.
No,
How
you
the
have shown only the
on the spatial thing.
spatial
Okay, okay,
dimension.
yes.
Okay.
Oh, yes, yes, definitely.
But other dimensions are also there.
Yes, yes.
Okay. Thank you. Thank you. Chuman, you have another question. Do you have another question? For whom? Same presenter? Yeah. To whom?
Hey,
Yes, sir. We can take two questions at least in one discussion.
Question.
Okay.
I have no right to ask question because they are students. Thank you. The question which is asked for stone quarrying, the answer is not right that. Answer is that we are going through capitalism era. We are greedy than needy, more greedy than needy. So there is no limit of development. So one fellow, he decided this, he replied this development in a very good way. Development means is the destruction of something. So this is development. I have some few suggestions. Within 2 minutes I will finish it. Shoreline change assessment to Devisha Ghosh. See, both of the presentation and flood susceptibility, both of you presented very well. But when you are presenting, you should keep in mind that what you are presenting, what is the role of women in shoreline change? Can you justify it? No. So why did you show this this data of population? Population data is required, but gender is not required. This way, so you should thrust on your study. This is okay. Devadrita. There is a difference between susceptibility and hazard. 1978 in 1978, Barnes, a famous geomorphologist, has given the definition. Susceptibility is a spatial phenomenon on the basis of the proneness. As a layman term, it is proneness. If we divide the area into different zones, this is susceptibility. And when we are incorporating temporal data on it to rectify the boundaries, this is hazard. Okay. So you have wasted time showing so many background studies. You have done good work, no problem. So when you are doing susceptibility, thrust on it. When you are doing management, thrust on it. You have incorporated 2 papers in fact. Okay. Thank you very much.
Thank you, Professor Dev, for your valuable advice to the young researchers. I hope that definitely going to help you in your future research. So going forward, as we are running out of time, so we'll have a parallel session. We will have poster session and as well as technical session too parallelly. So I request all the poster presenters, only the presenter, not all the authors. Please remember, only the presenter to go outside and stand in front of your poster. I request Professor Dey to take the charge of this poster session and provide your valuable suggestions to our students. So I request the poster presenters, only presenters, to go outside of the auditorium where the posters are displayed, to stay there. Rest of the participants will sit here and will have the technical session too. Only one presenter per poster. I repeat, only one presenter per poster, not everyone. Okay. Thank you so much for your cooperation. And now I would like to request all of you to take your seat. So I am going to start the technical session 2, and before starting I would like to also call upon stage Dr. Onu Rai, who is co-chairperson for this session, and she will be calling one by one the presenters, and presenters are requested to take your presentation in the pen drive, and please take care of the time as we are running out of time. Please complete your presentation within 5 to 6 minutes. Thank you.
Thank you, Dr. Mukherjee. The first presenter is the Mohammad Atiq Nawaz. Mohammad Atiq is going to present his work on predicting LULC change using CANN model and forecasting LST through the machine learning, a case study of Bangalore, urban India. Can we have Sameer Pramanik here? Mr. Sameer Pramanik? Okay. Rupayan Sardar, please be ready with your presentation. Devi Bhattacharya? Shayuni Sen Gupta? Okay. Please be ready with your presentation and come at the front, please. Come at the front, please.
Good afternoon, everyone. Myself, Mohammad Atiq Nawaz. I'm a student of Master's first semester, Department of Geography, Jamia Millia Islamia, New Delhi.
Hi, this is Sakshi, first year master's student from Department of Geography, CSRD, Jawaharlal Nehru University, New Delhi.
Our topic is predicting LULC change using CANN model and forecasting LST through machine learning, a case study of Bangalore, India.
I would like to begin with citing a very fascinating concept to the contemporary economy and people, more specifically in India, that is urbanization. Sometimes urbanization is quoted as synonym of development, guiding state and individuals to change the locations to megacity, might resembling the western cities. But the approach to the so-called development is an issue which is unplanned and highly dangerous to environment and consequently harming population. Getting an example of the situation, we can cite one of the most well-known megacity in the nation and a hub for biotechnology and information technology, that is Bangalore. Due to due to its high level of urbanization and industrialization, which draws many people, it is an epicenter of opportunity. The uneven growth of population and tertiary sector is putting burden on natural resources and infrastructure. Some of the visible results of these are the constantly reducing green spaces, encroachment and drying of wetlands, and overall changing LULC pattern with increasing concrete-based buildups. The LULC pattern is one of the prime controller of the microclimate, such as urban heat island by rising temperature. This situation need to be addressed, and one of the advanced way to do that and making plans is the use of geospatial tools.
The objective of the study is to compare the decadal changes of land use and land cover pattern and LST from 2013 to 2023. Additionally, the aim is to predict the LULC pattern and surface maximum and minimum temperature. By the way, it's average after a decade, that is 2033. If there will be no changes in the pace and way of development in the study area.
Coming to this study area, that is Bangalore district, which is located in the southern part of the Indian state of Karnataka at an average of around 900 meters above the sea level in Deccan Plateau region of the peninsular India. This district has a mix of land uses including residential, commercial, industrial and institutional areas. It is home to numerous institutions, research centers, IT parks, and industrial zones. The district is transferred by 2 rivers. However, these rivers have been heavily impacted by urbanization and pollution. Bangalore urban district is highly urbanized and densely populated. The district includes the city of Bangalore, which is primary urban center and capital of Karnataka. The city has witnessed rapid growth in infrastructure, commercial establishments, residential areas, and IT parks.
Now the methodology can be divided into 2 different sections, that is the LULC prediction and the other one is a temperature forecasting. So for LULC prediction, we took imageries from 2013 and 2023. With the help of supervised classification of both the years and ground verifications via Google Earth, we made that LULC map. And after that, we put both the maps into, for the modeling purpose, machine learning using CANN, that is Central Automata Artificial Neural Networks model. Specifically, the module we use, that was the plugin in the QGIS named as Molus. In the temperature forecasting, we use NASA database ranging from 1981 to 2022, and we use ARIMA model for the testing and training the data set and forecast the values that can happen in the near future.
Before going to the prediction or the forecasting, there is important to see the pastel decadal transition. Here is a transition of LULC pattern which is presented with the help of CANN model. Now here, as you can see in the mapping part, the face of city has been completely changed in a decade as the built-up has encroached the entire city. Talking into the numbers, here we can say that there's around 32% increase in the built-up area and simultaneously decreasing the very environmental friendly land covers, which is green area and the barren land. For the forecasting part, we have used very vital, or we can say land use and climate driving factors, NDVI and NDBI, which are representing the vegetation and the built-up zone of Bangalore city in 2013. Here is the forecasting for the 2033. Here you can see the complete city has been encroached with the built-up area, and it is not it. There is a very much decrease in all other very much natural friendly parameters, that are the wetlands, green zones, and the barren land as well. This much increase in the built-up is good enough to drastically change the environmental or the atmospheric condition of any a particular location, and that can be factually presented in the further slides.
Now, for temperature analysis, we use the model called ARIMA. We will be understanding the model itself in the subsequent slides. So here the first graph is showing the actual plot of the data we have extracted from the MERA satellite 2. And the second one is showing the trend. The third one is showing the seasonality. The seasonality is actually how, so basically the ARIMA model understands the data also, the date line also, the time frame. So it's understand how the April month of each year, for instance, are effective enough to bring those changes for all the months. So the seasonality is good. That means it has a good repetition of somewhere the same values. So the last but not the least graph is showing the residuals. Now, for ARIMA, we divide the whole data set into training and testing, how it performs. So let me simplify the training section. What it does that the model tries to understand the trend and seasonality, how it is happening. And then you test with the observed values. If it is overlapping easily, that means your model fits fine. So the ARIMA has 3 different sections. The AR is auto-regressive, that is the value of P. The value of D is integrating, or you can say value of D, and the last one is MA, that is moving average, the value of P. So the values of PDQ is equals to 1, 1, 1. After that, after we got satisfactory results, we modeled these things for the forecasting purpose, and here's the plot. Now we took the upper limit, or the maximum it can go, the worst scenario, and we can see the upward trend in all the months. I would like to bring your attention, in the month of April, we are seeing that the average temperature can rise up till 39 degree. That can assure us that in coming decades, the heat wave scenarios will get a very high frequency, and that's very inhabitable conditions for human. And likewise, the other months shows the same thing from July to December up till 2032.
So as we see in the initial slides, that the built-up area is increasing at a very faster rate in the city of Bangalore. And it is good enough, as I have stated before as well, to change the atmospheric condition of any city or any location. So with the help of ARIMA model, we have concluded that with the rising of built-up area, the temperature is also rising, and it will continuously rising at an extent which is very much problematic to the inhabitant of any particular location. So the concluding part over here is that there is a positive correlation, and direct positive correlation, between the rising built-up area, changing land use, land cover, and the rising temperature. Thank you so much for your patience.
Thank you.
Thank you so much. I would request all the audience, like, you please write down your question. We will take question answer at the end of this session. So the next presentation, I would like to call Rupayan Sardar. Please come on the stage to present your work on monitoring the spatio-temporal changes of land use and land cover in and around the paleo-channel network of the Western Ganges Delta using geoinformatics. Thank you.
Good afternoon. Here presents all academic staffs and my respected professors and my beloved junior seniors and dignitaries. So my topic, which is entitled as monitoring the spatio-temporal changes of land use and land cover in and around patio channel network of the Western Ganges Delta using geoinformatics. So basically my topic is about whole delta region. It's moribund delta, active delta and mature delta, all the delta region. So this is I focus to try to focus that about the paleo channels. The paleo channels are those channels which are totally disconnected with their parents rivers, or it semi-connected, or in times of mainly the monsoon times, it can connect with their parents rivers with a very limited or short small stretch. So the rivers of the Western Ganges Delta have lost their links, you know, that with their upper catchment rivers, so it can't contribute so much fresh water, so the water availability has decreased day by day. So basic objectives for this present study. The present study tries to identify the disconnected river channels in the Western Ganges Delta. Secondly, delineate a segment-wise in-channel land use and land cover classes, classify the disconnected paleo channels and their vicinity or proximity on the basis of land use and land cover pattern. And you see some photographs which is captured some stagnant portions of the Adi Ganga and Mathapanga Churni rivers. And my study area, this is actually mainly the 5 major river basins, which is Bhairav Jalangi, Mathapanga Churni, Ichamoti Jamuna, Vidyadhari and Adi Ganga. So my topic for the completions of this topic, I tried to categorize in 2 parts. One is for in-channel classifications and other is for buffer-wise land use land cover map. So in-channel classifications, I have it is categorized into 2 parts, and one is past path identifications and other is present path identification. So I tried to collect some data from Daniels map, US survey map, US survey map, Tassin's maps and Survey of India topoCity map to delineate the past conditions of the river or the past path. And for the present path, I use mainly Google Earth Pro and the field validation obviously. So thereafter I superimposed this past and present path, and I classified 12 classes, and there is some statistical analysis also there. And for the LULC change, I downloaded Landsat 4.5 and 8.9 images, then it's pre-processing at core, and it is also classified into 8 classes. And then I changed directions, then I have done the change direction on QGIS and perform a statistical analysis. This is the result and discussions part. Western Ganges Delta, you have seen this map. There are mainly 12 classes, what I have divided in channel performance. And these red portions and these red boxes are mainly the disconnected parts of those rivers channels. So I have identified more than 20 disconnected and seasonal disconnected areas on this whole Western Ganges Delta. And this is the bar diagram which shows the in-channel conditions, the present state or present conditions of the rivers. And thereafter, this is okay, sir. This is the descriptions. Segment-wise land use and land cover classified map has been prepared. So it has shows that total length of the Western Ganges Delta is about 2050.41 kilometer. Throughout these channels, 34.72% is covered by non-tidal channels, and followed by the stagnant water, tidal channel, arable land with settlement, aquaculture, stagnant water with fisheries, settlement, dry channel, settlement with vegetations, arable land with vegetations, and vegetations cover. And this is the buffer map of the Adi Ganga river basins. Mainly there are 2 major rivers, and the Toli Nala is also there. Adi Ganga, Piali, and Toli Nala. This is 1990 and 2000s, and there is 2010 and 2020 land cover map. And this is some statistical analysis where we see that the area covered by the vegetable crops has shown a significant increase in 2010, which could be due to changes in agricultural practice or shift towards more intensive agriculture. And the settlement with agriculture has remained relatively stable over the years. And this is the change detection map, where you see that the settlement with agriculture and the wasteland is converted mainly in vegetable. And this is a map of land use land cover buffer map, is Jamuna and Ishamati, 1990, 2000s, 2010 and 2020. And this is a statistical presentations and the bar diagram, which shows that the area of the water body has increased from 90 to 2020. The area of the natural vegetation also rapidly increased, and the arable land has increased in from 1990 and 2020. And this part is the change detection in case of Jamuna Ichamoti river basins. Fallow land and the wasteland turned into natural vegetation massively. Changing rate were 60.49 square kilometer and 24.12 square kilometer, whereas 12.12 square meter arable land turns into wasteland. And this is the map of LULC buffer map of Bhairav Jalongi, 1990, 2000, 2010 and 2020. And it shows that the mainly changes in arable land. So arable land is increased tremendously due to these 4 decades. And this is the change detection map. In case of Bhairav Jalongi river basins, fallow land and wasteland turned into arable land massively. Changing rates were 185 square kilometer. And this is the Vidyathari river basins, 2019 and 90, 2000, 2010 and 2020. Where you see the west land is also decreased day by day, and vegetables are the portions of the vegetables are increased in 2010. But
Rupayan, please try to conclude.
Okay. Oh, this is the change detection map. And Churni and Mathapanga Churni river basins. So it is concluded that the classes that experience the largest changes in land use and land cover with in different basins of the western Ganges Delta are settlement with agriculture and wasteland, while the water bodies and the natural vegetations have experienced the least amount of changes among the other land use classes. And we have considered that the total length, what I have said previously, and most of the part is covered up by non-tidal channel, is followed by stagnant water, tidal channel, arable land with settlements, and so on, so on. These are the references, and this is the acknowledgement part. Thank you.
Thank you so much. Now I would like to request Devi Bhattacharya to please come on the rise and present your work. Devi is going to present on the grey water footprints, a bibliometric analysis. Please try to complete your presentation in 8 minutes, right?
Very good afternoon, respected audience, and thank you, University, thank you, my professors, for providing me this wonderful opportunity to present here. Now, I am going to present about grey water footprint, a bibliometric analysis. To present, first thing, we should know that what is grey water. Let us see some examples of grey water. So, we can say that grey water is the kind of wastewater which can be generated from any source like kitchen, toilet, sink, basin, and washing machine, AC, and so on. Different researchers have suggested some definitions about grey water. Thus, we can classify grey water into broad two types, that is light grey water and dark grey water. The grey water which contains low level of pathogens is called light grey water. For example, we can say soap, shampoo, body wash, these are light grey water, and the water that contains high amount of pathogen is called dark grey water, which comes from the kitchen sinks, high oil, residuals, etc. These are the characteristics of grey water which shows the components of grey water. But it is obvious that it may vary from place to place because lots of pollutants, lots of chemicals are mixed with the grey water, and so that it can vary with place and time. Now, what is water footprint? We can say that the water footprint is an environmental indicator that measures the volume of fresh water used throughout the entire production chain of a consumer item or service. It can be of three types, that is blue water footprint, green water footprint, and grey water footprint. To come to the point, we should know first what is the grey water footprint. Grey water footprint is the volume of water which can dilute the pollutants of grey water. This is the way, thus we can calculate the grey water footprint of an area. So, the main objective of my research work is to understand the nature of grey water, to review the overall. Okay, sir. This is the. Yes, sir. This is the formula, thus we can calculate the grey water footprint. Okay, sir. Sir, may I continue? So, the main objective of my study is to understand the nature of grey water, to review the overall treatment method, to characterize grey water in terms of its physical and chemical composition, I can't change my slide, please come. Okay. And finally, to assess the grey water footprint. To do my research work, I have pursued the following steps, that is data gathering, data filtering, and data cleaning. It is because this research work is totally based on review paper, and it is totally based on the previous research work. So that I have collected different articles, journals, and books from different sources like Google Scholar, ResearchGate, Science Direct, and from there I have finally selected 441 research papers after screening. This is the map which shows the concentration of keywords. This is a simple bibliometric analysis which shows the name of the author who have contributed at least 5 papers in the field of grey water, and this right hand diagram shows the trend over time about the concernedness of grey water reuse and recycling. Thus, this is my literature review work, which shows some categories of literature reviews. These are some examples of grey water treatment system which is practiced around the world. We can see here that in different parts of the world, there are many countries who are practicing grey water recycling system. These are some plans of grey water recycling system collected from different articles and journals. These are the rough sketches of it. This is a technology we are very well known about it. It is practiced in Japan, that is the hand washed water is directly coming to the flush, and so that to prevent the wastage of water during the hand wash time. This is also some literature review work about grey water footprint. To pursue my research work with literature review, I have found some research gaps. That is, the data available for Kolkata city regarding the generation, reuse and policy of grey water treatment system in community buildings are not found to be adequate. Secondly, grey water management system installed in some schools by Government of India are either clogged or non-operating till now. Treatment technologies are also either very expensive or required regular maintenance, which is not practiced all over. And lastly, it can be said that most of the systems may suffer from failure because of biofilm formation in the pipes, which may cause a foul smell after some time. Hence, many treatment processes provide a disinfection step that further increases the cost of the recycling process. These are my references. Thank you for keeping patience.
Thank you, Devi, for completing in such a short time. Now I would request to come Shainu Sen Gupta to present her work on an integrated approach for climate change risk assessment in Kerala. I request all the audience, you please note down your questions. We will take a question answer after Shani's presentation. Thank you.
So, good afternoon everyone. My name is Shaini Gupta, and my topic is today my topic is an integrated approach for climate change risk assessment in Kerala. So nowadays climate change is very common all over the world, and this causing of the economic disruption and negatively impacting people's lives. So as we know that in Kerala we can see that flood So as we discussed that Nowadays, climate change is very common all over the world because of the economic disruption and negatively impacting people's lives. As we know that in Kerala we can see floods, droughts, landslides are very common nowadays. And as a result of the unexpected rainfall, Kerala experienced 331 landslides in 2018. On the other hand, droughts are also heavily influenced by the temperature rise in Kerala. The states also experienced a severe drought in 2016 as a result of insufficient rainfall caused by a 40% decrease in rainfall during the monsoon season. So these are the literature review of flood, drought and landslide. This is a study area. So as we know that Kerala is the southwestern coastal state of India and it is one of the smallest states in India. Kerala stretches from about 360 miles along the Malabar coast, varying in width from roughly. It is situated between the Arabian Sea to the west and the Western Ghat to the east. It is bordered by the Karnataka to the northeast. My objectives here: developing a composite climate change susceptibility model, developing a composite climate change vulnerability model and vulnerability index, and lastly risk assessment. This is my methodology. In this methodology, we can see that hazard predictor and controlling factors in flood, as we see that here, slopes, altitude, curvature, and these all are map are created, and I will explain part by part. So composite this map, then I create that susceptibility index and the validation, risk assessment and vulnerability assessments. These works are in progress. This is flood controlling factors. So this is elevation map. This map is prepared from SRTM, and we can see here that the less elevation is observed the western side of the map, and the highest elevation is observed southeastern side of the map. This is slope map in percentage. This is topographic wetness index. This.
No, this one. Elevation.
Yes.
Is it minus 48?
Yes, sir.
Oh, it is below sea level.
Yes, sir. This is in the yes. Less elevation is shown here. This is a slope map in percentage, and this is a topographic wetness index. This is the formula of topographic wetness index. In this formula, first we calculate the flow direction, then calculate flow accumulation, and then in raster calculator we calculate the slope, and then by the raster slope, and then create raster slope by using this formula, and then slope 10 and flow accumulation, finally to calculate topographic weighted index by this formula. This is a topographic position index. In this index helps us distinguish topographic features such as a hilltop, valley bottom, exposed ridge, flat plain, upper or lower slope. This is formula. In this formula, first we calculate the focal statistics by using DEM, and then the minus.
Where is the formula?
Sir, this is the formula. Just we search in ArcGIS that focal statistics by using DEM, and then we create a focal statistics map, and then we just search minus, and just add this in constant 1 we input the DEM, and constant 2 we input the focal statistics image. Then the topography position index is then created. Say oh, মানে calculation. This is a topographic ruggedness index. This index was developed by Relay et al. To express the amount of elevation difference between the adjacent cells of a DEM. This is a formula. In this formula, we calculate the focal statistics maximum, minimum, and mean by using DEM. And finally, to calculate TRI in raster calculator, we using this formula. This flow accumulation, vertical distance, LULC map. In this LULC map, the accuracy is 83.9%. This is a stream power index, stream density. This is rainfall. This is the HP data matrix for flood. This is the HP resulting weightage. This is flood susceptibility. In this flood susceptibility map, we can see the in the southwestern part is very high in flood susceptible, and the very low part is the eastern part. This is landslide controlling factors. This LULC and rainfall map. This fault map, and this fault map is collected from shear zone and crustal block of southern India, volume 2. This is stream order, and this is the HP data matrix for landslide. This is HP resulting weightage. This is landslide susceptibility map. These are the factors of drought controlling factors. This air temperature data. This data is collected from power axis point data, and we generated here in ArcGIS and then interpolated it. This HP data matrix for drought and HP resulting weightage, and this drought susceptibility map. In this map, we can see that drought is moderate in the western parts and high in the northwest parts. So, thank you.
Now the session is open for the question answer. I would like to ask the audience if you have any question to any of the participants. Raka, you are having a question, right?
Hi everyone, I'm Raka Hajra, student of BSc Geography, final year student. And I have a question to the presenter of predicting LULC change using CANN model and forecasting LST through machine learning. So my question is, you have taken the 10 years of data, right?
Exactly.
2013 to 2023. So you have shown only two maps. So can you tell me in which direction the built-up area has developed?
Which direction?
Yes.
Actually, if you can recall the map of 2033, then you might have seen that it has well scattered. So there is no definite direction of extension. What it does, if you understand, you can search online how the mollusk plugin in QGIS works. So there are two different terms. The module works, that is CANN, that also highlights. So CANN is actually cellular automata and artificial neural networks. If you can understand now why two data is only, not of previous. So there are only two inputs in mollusk, initial and final. So we choose a decadal changes. For 13 we choose the initial one, and the final is 2023, and that will give you exactly the same, and the interval you have, whatever the interval you have chosen, it will predict at the same interval. So if your input is 12 and 22, that is 10 years, then it will predict for 32. If your input is 13 and 23, that means a 10-year lag, then it will again predict for 10 years, that is 33. So likewise, there is two inputs and there is no any certain direction in which it is extension is there. The whole city is experiencing, experiencing the rise of built up.
Okay, but you could have shown that how much the LULC has changed. But LULC change means land use, land cover. Like in 2013, it was something like this, but in 2014, it might have changed. You can show that.
The LULC doesn't change in 1 year. For change,
it may be 0.001%,
but that cannot be used in the model itself. If there is no use in the model, why to show it?
No, I think I have a suggestion for you. What Raka is saying, I think she's unable to express this properly. The model you have shown, that is okay. The mollusk model, I noticed how it starts. But you can show the directions, like in which direction.
Okay. So the transition, whole transition.
Transitional, it's some directional eclipse, or you can use some other model to show which direction the built-up area is increasing or which direction it is increasing. And simply, you understand the rest of the problem.
Okay.
The direction is somewhere is shown, and it is basically from core to periphery. It is going in a multiple direction. There is no single direction, and that is why when we are looking the predicted data, it is spread to the entire city, and this is because of this direction. It is in multiple direction.
Thank you so much.
I have another question to grey water footprint, Ms. Devi Bhattacharya. So you are talking about that grey water recycling. So can you tell me the present condition in India for the grey water recycling?
Grey water recycling is practiced in some parts of India, but practically it is found that the institution which have started grey water recycling a few years ago, the instruments are clogged or instruments are jammed now, non-operative in most of the cases. So the condition is overall not very good in each part of India.
Thank you, ma'am.
Any more question? Yes.
first presenter. What is arithma model? Arima model. Oh, algorithm.
Algorithm. So it's a machine learning by Python, or you can also use in R language. So actually what you do, you take data and you refer it with the time series. So Arima is actually working on time series data. It understands the time, in which time also, not only in date format, and what is the scenario. Means if you have taken temperature, then it is temperature or any other variable, and it understands the trend, how it's happening. Then it understands the seasonality and the trend, then you train that data set. Okay. So in Arima there are different models, okay, and different values of PDQ, as I've mentioned. In different PDQ values, you try to overlay the same values which you have observed. If it has a satisfactory value, then you run those models for the forecasting values.
Okay.
Any more question? Any more question? Any more observation? Sir, you would like to say something? Any sir, your observation or your suggestion to any of the presenter?
Observation I can add.
Sure, sir.
Actually, Shani's paper is on an integrated approach for climate change risk assessment in Kerala. Actually, that should be a more in-depth study, and climate change is a major thing. You will have to check data for a very long period of time. Otherwise, you cannot say certain temporal anomalies do not indicate that there has been a change in climate. Okay, so if you want to do your research in this direction, you will have to go have some in-depth study. Okay, moreover, I should, as you are my student, I should say that you will have to explain your things in a better way. Okay, just do not mention the things in the slide, but if you do that, then please explain. All of us are not supposed to know everything. Okay, so you'll have to explain those things, and whenever you say climate change, you will have to substantiate it. Okay, thank you.
Thank you so much, sir. On behalf of my chairperson, Dr. Mukherjee, I, Dr. Anu Rai, congratulate all of you. In this session, we have 4 presentations from the different era. We have presentation on the LULC prediction model. We have presentation on the land use and land cover change in and around the paleo channel network, and then grey water footprinting, and then an integrated approach of a climate change risk assessment for the Kerala. So for different area, for the different presentation, I would like to congratulate all of you for your beautiful work. Being the chairperson of the session, I would just like to recommend something to a few of the participants. Like, I think you have received a lot of suggestions from the Kasturi Mukherjee ma'am. Try to incorporate some of the statistical significance also to your model, so that we can understand this model is running well or not. So that is also important part. Secondly, I would suggest Rupayan, that whenever you are presenting, don't say that this is the statistic, this is the data, or this is the thing. Your work is very interesting. It was like a very wonderful work. So you can also add some kind of more information about the more interpretation, rather than showing that this is a table, this is the statistic, this is the something. You can interpret your result. It means what you have found exactly. So that will add more essence to your presentation. My suggestion to Devi, that we were expecting some more explanation from your end, like, because your topic was grey water, review of the grey water, and then you have shown lot of literature, you have studied also lot of literature. So out of those literature, what exactly you found? So we were expecting that you would be going to discuss something about the nature of the grey water as well. That was missing from your presentation. For Shayani, I'll suggest that Shayani, you please check with your data set. I think there are some error in your calculations because when you're showing Kerala, 80% of Kerala is not under water. It was your elevation was minus 48 meter. It's like, I think it's an error of the algorithm or error with the data set. So you please check that, and best wishes to all of you. All the best, thank you. After that, we will move towards.
Just 1 minute. In connection with Devi's paper, Devi, you have mentioned nature of grey water. Then there was another bullet, physical and chemical composition. Are those different? Is it type of grey water? So you will have to mention it as type. When you say nature, physical and chemical composition is obviously related to the nature. Okay.
Okay, thank you so much. Now we have come to the end of this session. Your snack is like waiting outside. Parallelly, we have also started another session, technical session 4. So I would request all of you, like we can go 50:50 ratio. So some of us can be here. So our presentation would be shown very soon here. And some of us can go outside and can take our snack, and then we can come back here again. So our online session is already started.